Here we are with Chapter 3 Guided Notes Part 2. This is the screencast that guides you through them. So when you're going to fill the blanks in this guided notes document, which is right here, okay, you're going to fill in these blanks. Make sure you create a copy, put it in the folder that is shared with me. Make sure it's in the folder that you shared editing rights with me. And then we're going to go through this PowerPoint, okay? So we're starting at slide 9. On subatomic particles. So this is protons, neutrons, and electrons. The subatomic particles were discovered soon after Dalton came up with his idea of the atomic theory. Soon after that, the first particle to be discovered was the electron, followed closely by the proton, and then it wasn't for another maybe 100 years that they discovered the neutron because it's so because it doesn't have a charge. And that's kind of the way that they went about doing that. So the smaller parts that make up atoms are called subatomic particles. The three most important subatomic particles that we're going to talk about are the electron, the proton, and the neutron. The atomic number is equal to the number of protons. That is a number that doesn't change. It's an identifying characteristic of an atom. In a neutral atom, it also equals the number of electrons. But if the particle has a charge, if it's an ion, and then the number of electrons is different than the number of protons. You can calculate the charge of an atom by taking the number of protons minus the number of electrons. Then you have the mass number. The mass number is the number of protons plus the number of neutrons. Now this could be different for different isotopes. All elements are samples of elements will be a mixture of different isotopes of that element, and so the number of protons and the number of neutrons is important for discerning different isotopes. And here we go. Isotopes is an atom that has the same number of protons but a different number of neutrons. For example, there's a couple different isotopes of carbon. Carbon-12 is the most common isotope. It has 6 protons and 6 neutrons, but carbon-14 is a very important isotope because it is used for dating dinosaur bones and fossils and the like. Okay, that has 6 protons and 8 neutrons. The thing about carbon-14 is that carbon-14 is radioactive, and so they can use the amount of carbon-14 that is present in a sample to determine the age of that sample. So depending upon how much carbon-14 is left, depends upon how old that thing is. That's why it's used for determining the age of fossils. Moles is a great unit, and we're going to use it. It is exclusive for chemistry. A mole is the number of atoms in exactly 12 grams of carbon-12. That is how it was defined. And a mole is the chemist's dozen, if you will. A mole is 6.02 times 10 to the 23rd particles. And so if you're talking about in atoms, it is 6.02 times 10 to the 23rd atoms. But it is used to dole out amounts of things, right? Just like if you go to the baker and you ask them for donuts, you generally order donuts by the dozen. When you're in chemistry class, you dole out atoms by the mole, okay? So it's just a unit, right? And this is a picture of Avogadro. Avogadro's number is the number of atoms in a mole. Avogadro wasn't the one that discovered the mole or anything like that. He's just a bug-eyed chemist that we've named the number after. And so moles are the SI unit for the amount of a substance. The molar mass of a substance is equal to the mass in grams of a mole of an element or a compound. So the molar mass is the same number as the atomic mass, or the mass number. So when you're talking about mass number, you're referring to the number of protons and neutrons. When you're talking about molar mass, you're using the same number, right? It's just telling you how many grams are in a mole of that substance. Okay, and so then of course, we have cute memes that we can come up with this because a mole is also a small fur creature that lives underground. And so you have a mole is equal to 6.02 times 10 to the 23rd. And then, of course, chemistry cat memes, they're going to abound. And so you should watch this video. This is a video that describes how big a mole is. It's important. It's good. And I'm not going to click on it now because it doesn't really lend itself to a screencast, but there you go. So that should be it. Oh, right, obviously converting. Right, so in order to convert from grams to moles or from moles to molar mass, you're going to use this handy-dandy triangle. And in this handy-dandy triangle, all you do is you cover up what you want and then it tells you what to do. So if you cover up the moles, if you covered up this number, right, it would be mass divided by formula mass, right? And that tells you what to do. And if you wanted to figure out the mass, you cover up the mass, and then that is equal to moles times the formula mass because they're next to each other. So this conversion triangle, super awesome to use. It's super easy to use, and we're going to do some practice with that. So here's how you do the same thing for atoms or molecules using Avogadro's number. So Avogadro's number is 6.02 times 10 to the 23rd. And so if you wanted to calculate the number of atoms in a sample, you take the moles times 6.02 times 10 to the 23rd because they're next to each other. If you want to determine the number of moles, then you take the atoms or molecules divided by 6.02 times 10 to the 23rd. Hopefully this helps make things more clear for you, and you should have all the things that you need for this guided notes activity, right? You should have all the blanks that you can fill in there, and then there's a little part at the bottom with the triangles. And you should be good to go. Make sure you save this into your Google Drive once you've completed it, and then upload it to this assignment. Okay? Have a great day, and I'll talk to you guys soon.